So in exercise 5, we are revisiting the monopolist exercise that we had in one of the exercise sessions. So we have the company Massive Products, which is a monopolist and who has cost of production given by 20 times the quantity which is produced plus 5 times the quantity by the power of 2. And therefore the marginal cost curve, which is then the inverse supply curve, if you take the derivative, is equal to 20 plus 10 times Q. The demand function in this market for the product is given by 100 minus P. In sub-exercise A, we are asked what price will the monopolist charge and what profits will the monopolist earn. What will consumer surplus be? Okay, let's start. So we have an inverse, we have a demand which is equal to 100 minus capital P. And therefore our inverse demand, so the price depending on the quantity, is equal to 100 minus Q. And since we have a monopolist here, he can either choose prices or the quantities. It doesn't matter. Yeah, so it's different than what we would have in perfect competition and what we would have in an oligopoly. Yeah, so here the monopolist can either choose the price or the quantity that he's producing. So what's the optimization problem of the monopolist? So the monopolist maximizes the following. Oops, there's something missing. Maximizes the following. So he's maximizing revenues minus costs. Yeah, so revenue minus costs. And the revenue is simply given by the price. So here the inverse demand, 100 minus Q, times the quantity, which is then Q, minus the costs depending on the amount of production. Yeah, so here we're choosing so we let the monopolist choose the optimal quantity, which maximizes profit, rather than the price, because we are giving a cost function, which depends on the quantity. So 100 minus Q times Q, minus 20 times Q, minus 5 times Q by the power of 2. And if we derive the first order condition, what we get is 100 minus 2Q minus 20Q minus, sorry, not 20Q, but just 20 minus 10 times Q, and this should be equal to 0. If you solve this, you get Q star is equal to 20 divided by 3. So this is the optimal or the profit maximizing quantity that the monopolist is producing. Plugging this back into the inverse demand function gives us then P star, which is equal to 280 divided by 3. And given those values, we can calculate the producer rent, which is here in this case where we do not have any fixed costs of production, simply the profit of the monopolist. Yes, so producer rent, or the producer rent here, is simply given by the profit. So then it's simply 100 minus Q star divided by Q star minus 20 times Q star minus 5 times Q star by the power of 2. And if you plug in all the values, you end up with roughly 266.7. So this is the profit of the firm, and hence here the producer rent. And the consumer rent can be also calculated quite easily. So if you look at the demand function here, the price above which there is no demand is equal to 100. So this is kind of corresponding to the maximum willingness to pay that the consumer has in this market. So we take the 100. From this, we subtract the equilibrium, or the monopolist price, which is 280 divided by 3. We multiply this with the quantity which is traded. So this is the amount demanded by all consumers in the market which have a willingness to pay equal or larger than the monopolist's price. divide this by 2, and this is roughly equal to 22.22. So the total welfare, if we add up, is then simply something around 288.9. Okay, so this is the total welfare if there is a monopolist on the market and there are no taxes. Now, in sub-exercise B, we are confronted with a situation where a government is imposing a tax. So how will the monopolist's price and profits change if a tax of X dollars per unit is imposed on the buyers of the product? Yes, so the consumers have to pay X dollars in addition to the price if they are buying the product. Now the question is, how does everything change? Okay, so let me just go to a new page. So now the demand function is 100 minus P plus X. And hence, the inverse demand function is 100 minus Q times X. Okay, so this is now the inverse demand function, given that there is a tax of X on the buyers. So now the monopolist maximizes. He maximizes the following. So this is the price, given that he's choosing some particular amount of quantity which he produces, times the quantity that he's producing, minus the costs, which are unchanged. So if you maximize, so if you derive the first order condition and maximize this, what you get is Q star being equal to 20 divided by 3 minus X divided by 12. And if you plug this in to the inverse demand function, you get 280 divided by 3 minus 11 divided by 12 times X. Good, so those are the profit maximizing quantity and prices if there is a tax of X on the consumers. Now what we can do is we can calculate again the consumer rent and the producer rent, so the formulas are basically the same as before. So let me just write this down real quick. So the consumer rent again is simply 100 minus, let me just check the price. So it's 280 minus 11 divided by 12. So it's 280 divided by 3 plus, because it's minus, 11 divided by 12 times X times the quantity which is traded. This is 20 divided by 3. 20 divided by 3 minus X divided by 12. And we divide this by 2. And this is roughly 22.22 plus 25 divided by 9 times X minus 11 divided by 288 times X by the power of 2. And the producer rent, or the profit here in this case, is roughly equal to, so I will shortcut the formula because basically you just change the price and the quantities, the rest is the same. So the producer rent is 266.7 minus 20 divided by 3 times X minus 143 divided by 24 times X by the power of 2. Therefore, if we add up consumer rent and producer rent, the welfare is then 288.9 minus 1727 divided by 200, I think it's 88, yeah, times x by the power of 2 minus 35 divided by 9 times x. So this is basically the welfare depending on the tax x. And if we consider the deadweight loss, you remember that the welfare before was 288.9. So the deadweight loss is then simply the absolute value of those terms here. So the deadweight loss is given by 1,727 divided by 288 times x by the power of 2 plus 35 divided by 9 times x. And the deadweight loss is a strictly increasing and strictly convex function of taxes in this economy on the demand side. But keep in mind that x cannot simply be arbitrarily high, because if x would be larger than 100, then this market wouldn't exist, because the tax would be higher than the maximum willingness to pay for the product in this market. Yeah. So for any tax which is below 100 and strictly larger than 0, the deadweight loss is strictly increasing and strictly convex. And the reason is simply because tax distorts again the market, in that some consumers which have a high willingness to pay for the product do not buy it, even though the kind of production cost for this marginal unit for the monopolist would be strictly lower than their willingness to pay. But due to the tax, it is not, and hence there is an inefficiency here. So trade is not happening, even though both could improve their situation if they would trade. So both the consumer and the monopolist. And this explains why the deadweight loss here is strictly increasing in the tax. And since it's convex, actually, it's getting worse and worse the higher the tax basically is. And this finishes exercise number 5. Oh, so I actually I did 2 sub-exercises in one. So I already did, so this is B and C. So I did 2 sub-exercises in one. So then let's go to sub-exercise or exercise number 6. So suppose that for every hour you work, you can earn $5 before taxes. Furthermore, suppose that you can work up to 16 hours per day, 365 days per year. Draw your annual budget constraint reflecting the consumption leisure trade-off under each of the following income tax schemes. So the first tax scheme is a flat income tax of 10% on all income which is earned. So yeah, let's consider this. And before we start, let us consider the following. So what's the maximum amount of leisure that we can consume? So the maximum leisure would be if we do not work at all and we simply, just spend free time. So we can do this up to 16 hours per day, because for the remaining 8 hours we're sleeping, and we can do this every day. So that's 365. And this is equal to 5,840. Yeah, so we can have a maximum leisure of 5,840 hours per year. On the other hand, if we do not enjoy any leisure at all, but we work, we can consume at most 5,840 hours times the wage that we're getting, which is 5, which is then 29,200. So if there aren't any taxes, the maximum amount of consumption that we can have if we fully work is given by $29,200, and independent of whether there is a tax or not, the maximum leisure that we can enjoy is $5,840. And in sub-exercise A, we are considering a flat tax of, I think it was 10%. Let me just recheck. Yes, on all income which is earned. So yeah, let's draw the coordinate system. So we will put leisure on the x-axis and consumption here on the y-axis. So the maximum amount of leisure that one can consume with and without the tax is 5,840. And what differs is, so when we're comparing the no tax and the tax situation, is the maximum consumption. So as I showed you before, if there is no tax, what we can consume at most is 29,200. And by connecting the two lines here, I will try to do it as straight as possible. This is the budget constraint if there is no tax. And if we have taxes of 10%, like a 10% flat tax rate, then what we get is 29,200 times 0.9, which is then equal to 26,280. And this gives us, brings us somewhere here. So please keep in mind when I'm drawing, the scales are not very correct here, like the geometric scales. So I will try to just draw it in a way that it becomes clear what I'm meaning, but I will not be 100% clean here because it would take too much time. So 26,280. And if we then connect, oops, okay, it's a straight line, nice. So this would be the constraint with tax. So as you can see, the slope of this, let's call it a budget constraint, is lower when there is tax. And the reason is because the opportunity costs of leisure are decreasing when there is a tax, because you give up less net wage when there is a tax compared to a situation where there is no tax. Yeah, so this is the reason why, if you're looking at the coordinate system like this with leisure on the x-axis and consumption on the y-axis, the budget constraint becomes flatter if there is a tax. Okay, so let me just quickly copy this coordinate system because we will use it again in exercise number B. So just put it here. I'll just get rid of some of the stuff. Oops, sorry, misclicked. Okay, so in sub-exercise B, we have the following situation. We have an income tax where we pay no tax on the first $5,000 which we earn. And then there is a tax of 25% on all income over $5,000. Okay, so the first thing which we need to find out is how much do we need to work in order to earn $5,000? So since we have a gross wage, so a before tax wage of $5, we have to work for 1,000 hours in order to earn $5,000. So this brings us somewhere here. So if we enjoy 4,840 units of leisure, this gives us 5,000 units of income, which is then fully consumable because for up to $5,000, we're not paying any taxes at all. So this is basically what we can enjoy. So if you would draw the budget constraint, it would coincide with the original budget constraint where there is no tax because we're not paying any tax for the first 1,000 units of work that we're conducting. But then, of course, there is a change in that the maximum amount of consumption is changing when we are then fully working because we have to pay 25% of taxes for all gross income over $5,000. So how much is the maximum amount that we can consume? Well, it's given by $5,000. So the first $5,000 which we do not pay taxes on, plus the remaining amount that we can earn. So $29,200, which is then without taxes, minus $5,000, which we do not pay taxes for. And this gets multiplied with 0.75 because that's what's remained, like that's the net income that we have for all income above $5,000. And if you calculate this, you get 23,150. And yeah, let's put it somewhere, I don't know. So let's put it somewhere here, just to make sure that you see that the kind of budget constraint now will become flatter. So it's 23,150. And basically now the budget constraint is going from here to here, to this point. And this is kind of this here is the budget constraint or the consumption leisure trade-off set, opportunity set, which reflects the tax schedule where we are paying no tax until $5,000, which is here, and then up to the maximum amount of consumption that we can get, we pay 25%. And as you can see here, compared to the no tax situation, again, the this budget constraint becomes flatter if we earn more than $5,000 because we basically have less opportunity costs of leisure due to the tax increase here. Okay, this brings us to the last exercise where we first have to calculate something. So let me then again, I think we won't need the same picture. No, we don't need it for the last step exercise. So the last sub exercise, this is a little bit more demanding. So we have an income tax where you pay 10% on the first $5,000 earned, 20% on the next $10,000 earned, and then it's X% thereafter. So the question is, find first, before we draw, find X such that your maximum consumption, if you work fully, is equal to 15,000. Okay, so in the first step, we're asked to find kind of the marginal tax rate for income above 15,000 such that we end up, so if we fully work, we end up with a maximum consumption of $15,000. Okay, so let's start with the calculation. So how can we calculate this? So for the first $5,000 in this tax schedule, we're paying 10%. So what we are basically getting from this part of the tax bracket, the tax schedule, is at most 5,000 times 0.9. So this is kind of if we work until we earn $5,000 gross, this is what we get net from this. To this, we add the next $10,000 of work that we have times 0.8. Okay, so this is the next tax bracket where we are taxed with 20%. And now comes the new thing. So the maximum amount of consumption that we could conduct without taxes would be 29,200. From this, we subtract so the amount of our taxable income, which we, so where the tax brackets, the lower tax brackets were applied already. So that's 15,000. And this is the remaining amount of your income, which will be taxed with X%. So what's remaining is then 1 minus X. That's basically, so what you see here is what you can consume in maximum given X if you fully work. Okay, so this should be equal to 15,000. And if you solve this with respect to X, what you get is that X is roughly about 0.8239, and hence the marginal tax bracket, tax rate for all income above 15,000 should be 82.39%. So very high tax rate, such that when you're fully working, you earn an income or the maximum consumption that you can conduct is 15,000. So let's draw this. So again, we have leisure and consumption here. So the maximum amount of leisure that we can conduct is 5,840. In order to be able to earn $5,000 gross, we need to put in 1,000 hours of work. So the next point of interest will be somewhere here. Sorry, just be a little bit more clean. So it will be somewhere here. And this declares the point where we are earning a gross income above $5,000. And the next point of interest is when we're earning more than $15,000, which is then on top of the $5,000 gross, we need to earn additional $10,000. So how can we earn $10,000? So this is done by working 2,000 hours. So then the next point of interest will be somewhere here. So this is then 2,840. And for each of those points, we receive kind of a particular value for consumption. So if we work for 5,000, so if we work for 1,000 hours, what we earn is an income. Let me just draw this real quick. So if we work for 1,000 hours, we get a gross income of $5,000. And this will be taxed with 10%. Hence, we can consume a maximum of $4,500, okay, if we work for 1,000 hours. Then if we work for additional 2,000 hours, the maximum that we can then consume is the following. So it's $12,500. So this is the $4,500 plus the 8,000 that we can consume from the additional $10,000 that we are consuming. So it's basically then additional $10,000 of gross income multiply with 0.8. Yeah, so this is then on top of the $4,500 and gives us in total 12,500. So then the next point of interest would be here. So, okay, this doesn't look flat at all. So let me just put it a little bit lower. So let's put it somewhere here because it should be becoming flatter. That's the point. So the next point of interest would then be here. Okay, this looks a little bit better. Okay, so yeah, think of a little bit flatter line. And then if we fully work, we calculated before that with this tax rate of 82.39% on any gross income above 15,000, we can earn 15,000. So this would be somewhere here. And if we then connect the last part, it should be even flatter. So basically what we have is a budget constraint reflecting consumption and leisure such that the this should be also linear here. It looks a little bit, so it looks a little bit non-linear, but this line here should actually be linear. Yeah. Just 1 second. Let me just correct this real quick. Yes. So it should look somehow like this. So the more you get into this direction, the steeper, the flatter this budget constraint becomes because the opportunity costs of leisure are decreasing more and more the more taxes you're paying. Yeah, so this is the reason why it becomes steeper. And yes, I think this finishes this week's problem set, which was the recap problem set for chapters 2 to 6. Yes, we're done. So next week we will do another recap problem set just to make sure that then we are aligned with the lecture, so I'm not too fast. So yeah, I will create some more exercises for the next week, and they will differ from what I have done this week, yeah, in this problem set. So then see you next week.